All right, welcome everyone. In this video, we are going to discuss how we can import a shapefile as an SF object. So a data scientist, when we're working with spatial data, it's most likely that we're going to be importing that data, the SF object, from a shapefile into R rather than constructing all of it ourselves as we did in some of the previous videos. So a shapefile is by definition a non-topological format for storing geometric location and attribute information of geographic features. So basically, a shapefile is a simple feature because it includes geometric locations and attributes for at each of those locations. So those are the two components we need for a simple feature. The geographic features in a shapefile, these can be points, lines, or polygons. So those are the geometric objects that we can work with in a shapefile. So if you want to learn some more about it, there's a link over here with more information about shapefiles. But generally speaking, it's pretty simple to import a shapefile into R as an SF object. It's going to have the same structure as the ones that we created ourselves. Each row is going to be an observation associated to a different geometric object. We should have a geometric column, which is giving us, it's kind of like the geometric list column, where each entry in that list is going to be a different object. And then all of the other columns are going to be the attributes associated with each geometric object. And so shapefiles, these are available online. If you do some Google searches and include shapefile in your Google search, you're bound to find some of these. So these are, you might not have heard about them before, but they're very popular, used among people that work in geographic information systems, and other kind of spatial recognition fields that if you do a search in Google and with whatever you're interested in with shapefile in it, you're likely to find the link to a page that has the shapefile you're interested in. But we can use shapefiles to describe things like states and counties, which is what we're going to work with in this video. But we could also use it for roads and rivers and lakes and trees and other things. Um, so these shape files are often stored as a zip folder, and there's going to be a bunch of files inside of that zip folder. And the one we want, the shape file, has an extension of .shp for shape. And so here's a link to the census website for the US government. If you click on this, it takes you over to a website like this one. And the data that we're going to work with, I got by downloading this shapefile right here. So this created a zip file with several zip files inside of it. And so I was able to track down the shapefile that I wanted, downloading this link over here. But I have this information loaded and ready to go for you. So you don't have to click on this link and download it yourselves. I've got it set up in this notebook, in this project. So in this case, we can import a shape file as an SF object using the st_read function. So if you have a shape file, that's how we read it in. And if that shape file is set up correctly, then it's going to create an SF object for us directly from that file. And the st_read function, just really, there's one argument that we really need to enter, which is what is the name of the file and what directory is it living in. So we just need to give it a DSN argument, which is the data source name. So how I went through this process is I went to this website, I downloaded that shape file. It had a zip file of a bunch of other zip files. And inside of that, I identified the zip file that I want, which had this name. And then we unzip this, and inside there is a shaped file. So what's important is if you are working in Posit Cloud, there is a folder that's already created for you called data. And inside of that folder, I updated this. So you might have a version that has 2018. If you have an older version, you'll just want to export the Posit Cloud project again into your own directory so that you have the most updated data from 2023. So inside the data folder in our main project is another folder which is has this name. And if you click on this folder, you can see the shape file that we're going to use to create our SF object. So all of this is done for you if you're working in the cloud. So there's nothing that you're going to need to fiddle with. If you are working locally on your own computer, so you've downloaded our studio, then I set up some code cells over here that will get you to download that data and have it into a similar file structure. So one thing I want to point out is just how we're managing files, whether that's on the Posit Cloud or in your own local copy of working with RStudio. So there is a function called get working directory, which will get the current working directory. So in other words, this is where it assumes I want to read files from. So this is like my main default project folder that we saw over here. And if I want to read in a file, such as the one that I had before, then this is telling me what is kind of like the root directory that I'm working from. So this is helping me navigate to where this shapefile is. So this is telling me, based on my current working directory, which is the project, go into the data folder, then go into this folder and pull off this file. So it's going to find this file over here. So that is one way that we could do it. If you prefer, you could set this as our working directory, or we could set data as our working directory. We can change our working directory. So this might be of interest for people that are working RStudio locally on your computer. So if you want to change the working directory with a Quarto document, it works a little bit differently. So what I can do, let me insert a new code cell over here. So I'm going to insert our code cell. So I could set the working directory, for example, to data, and then check the working directory after doing that. And this has set the working directory. You can see over here, I changed it to data, and then I wanted to check to see whether that worked. And I get a warning here that says this has only been applied to this single cell. So if I come back to my first code cell over here and run this, it still has the working directory set for project. So when I change the working directory, it only changes it for one code cell, which may be good, that may be bad. If you do want to change the working directory for every code cell in a Quarto file, then you would need to work with an R setup. Well, there's different ways to do it, but one way to do it is to use an R setup code chunk. At the very start of your file, we indicate that it's a setup code chunk. I have this execution option because I don't want to print this out when we render this to an HTML file. So this is going to kind of ignore this code cell when we render it to HTML. But what I could do, this is what my current root directory is by default. If I wanted to change it to data, for example, everywhere, I could run this setup code cell, come back over here, and now, where am I? We are down here. Now, if I check my working directory, this actually changed the working directory for every code cell in this file. But I want to leave my working directory as my current directory where this file lives. So I'm going to run this code cell again to change the working directory back to the default, which is the project directory if you're working in Posit Cloud. So I've commented this out. So if you open up this notebook, it's actually not going to run this code cell. And your working directory by default would be the project working directory. Or if you're working on your computer, the default working directory is going to be the directory where the file you're working with is. Okay, so I set our working directory back to the default, and I can see that over here.